Hi everyone, how are you guys? Can you all uh, share your video with me also that I can see you all. We will start when everyone join. Like let's wait for another 2 minutes and then we will start. So can you guys give me a short introduction like from where you are, like from where you have done BTech or doing BTech, and why do you want to pursue GATE or further studies in metallurgy? Like any one of you. Then we will start the session. So Kanya, you want to tell us something?
Good evening, sir.
Yeah. Just introduce yourself a little bit.
I'm Sukanya Bani. I'm from Odisha
Okay.
and I'm currently in seventh semester.
Okay, means you are in final year right now.
Yes, sir.
From where?
Sir, from Odisha.
No, college I am asking.
Sir, Indira Gandhi Institute of Technology.
Okay. Nice. So any purpose for you to come here and join these sessions? Like what you expect from these sessions? Okay. Like Manas, you want to introduce yourself? Short brief introduction from where you are and what you want to have from this course or these tutorials. Anyone else? If not, let's start in another 1 minute or so. Like already it is 6:06. We'll start in 1 minute. So let me introduce you first with who am I. Like I am Swanand Telpande, currently pursuing PhD in ISC Bangalore. I am a PMRF student and I need to complete a teaching assistantship, which is mandatory for a PMRF to get outreach students and know like interact with students like how they feel about metallurgy and lot more so discuss science with them. So here I am to we will meet every week and we will cover most of the topics which will be basically physical metallurgy, mechanical metallurgy, all the topics which are covered in GATE, and we will focus on previous year questions in order to address and like what kind of questions are asked in GATE exams, and you should be ready for that type of questions if you are appearing for GATE examination. So we will more or less discuss 3-4 questions in one session, and you can have doubts regarding those questions, and we will try to answer the things. So mostly you will have to read the material which is shared with you previously, like look at the videos, what they are, like what concepts are there in GATE, and we will just try to apply those concepts in the questions. That is the overall idea of this session, and we will try to interact with each other and try to know that how we can improve on your GATE skills. Like it is a 3 hours paper and you need to solve like around 55-65 questions in that. So how to manage time in that and other things we will discuss here. So okay, so if no one is joining more, let's start with what today we will do. I will present my screen. uh, just a second. Just let me know whether you can see my screen or not. Can you see my screen? Okay. Can you see the PowerPoint presentation? Any one of you just say yes or no. Then I will start. Hello, hello. Am I audible? Okay, let's start. So here, okay, I have introduced to everyone that I am Swanand Telpande, currently a PMRF research scholar in ISC Bangalore. So I will take you with some of the metallurgical engineering previous year questions, and what I will do is like I will have 3-4 topics, like each question from different topics. Let's say like solidification and mechanical metallurgy, for example fatigue and everything. I will take one question, like we will do 3 questions today, and let's figure it out like how we can solve these questions in efficiently by knowing the science what is behind that. So okay, so let me come to first question. Like this question I have taken from GATE 2016, and this is question number 20. The question states that the operational which is not associated with casting is like they have given 4 options. One is gating, second one is fettling, third one is stack molding, and fourth one is calendaring. So we need to choose the option which is not associated with casting. So first try to understand what these 4 options mean. First is gating. So what is gating means is like gate system, which is often used in casting, which is a metal pouring system that conducts molten metal into the mold cavity. As you can see here, this is a casting which we want to like solidify. So here a gating system is required. So gating system consists of one pouring basin, sprue valve, choke, runner, and these ingates. So this gating system is required, which is a necessary system so that our casting remains in a good condition, and riser is there to know that the every each and every corner of casting is filled with molten metal, and the molten metal will come out of that, which will ensure that every part of this casting is filled with molten metal. So gating is associated with casting. So what is fettling? Fettling is basically removal of excess material from casting such as gate, riser. So after this is solidified, this complete setup is solidified, you can see here you can cut this thing. We need to cut these things as well as the riser so that our casting is finally ready. Hence fettling is the process where we remove these kind of other things from the casting. So fettling is also associated with
So your
casting.
voice is not audible.
Oh, okay. Screen is visible correctly? Hello? Screen is visible? Hello? Hello? Is screen visible?
Yes, sir.
Okay, okay. I will just shift my network to some other network. Just a second. Was I muted from start?
Yes, sir.
Oh, okay, okay. I will start the session again. Okay. Sorry. Okay. Now I am audible, right? And my screen is also
Yes, sir.
visible. Yeah.
Yes, sir.
Okay, okay. So this session, let me introduce you that I am Swanand Telpande. I am a PMRF research scholar from ISC Bangalore. So I will conduct these GATE tutorial sessions, which will consist of previous year GATE questions and how we can solve these questions in limited time by understanding the science behind them. So I will take care of like many topics which include physical metallurgy, mechanical metallurgy, as well as solidification and casting and crystallography, characterization, etc. So I will try to choose the questions which are related to only specific topic. In today's session I will cover like one question of different topic. So we will usually have 3 to 4 questions in one session, so that we like I can tell you how we can solve these questions, and you can also ask doubts regarding those questions. So we will cover in today's lecture we will cover three basic fundamental questions which are let's say from GATE 2016. This is the question which is asked in GATE Metallurgical Engineering GATE 2016 question 20, which asks us that the operation which is not associated with casting. So out of the 4 options, which option is not associated with casting? So 4 options are: first one is gating, second one is fettling, third one is stack molding, and fourth one is calendering. So in order to answer this question, we should know all the 4 operations. What are the 4 operations? So first one is gating. So gating system is basically a metal pouring system that conducts molten metal into the mold cavity. So here, as you can see, this is a casting which requires this assembly, which is the pouring system, or let's say a gating system. So gating system consists of: one is the pouring basin attached with sprue. So from here we will pour the molten metal, and this is the runner which provides the molten material through these ingates to the casting, and this is the riser to check that whether all the parts of molten metal are present in the casting or not. So if molten metal rises from this riser, hence we are assured that all the parts of this casting are filled with molten metal. So gating is associated with casting. Second one is fettling. So after this is solidified completely, we need to remove these parts out of casting, and this is our final product. Hence the process of removal of excess materials from casting such as gate, riser, etc. is known as fettling. So fettling is also associated with casting. Now what is stack molding? So let's say if I have this casting, I just bring it like more castings in series with this casting. So a series of molding phases stacked together to create multiple phases or level of molding. So this is required in industrial application, because if you have one riser and if you have series of molds, then you are like solidifying metal through a one gate system also. And the advantages is like the increase of output which is required in industry of a given molding machine. Let's say I want to have 400 molds in a particular hour. So this is like used in industry to just increase the output. So stack molding is also associated with casting. And fourth one is calendering. So what is calendering? Calendering is basically a process of smoothing and compression of a material. It may be a paper, it may be some polymer or any other material during the production by passing single continuous sheet through a number of pair of heated rolls. So as you can see the schematic, this is the thin sheet which is passed with number of rollers there, and the thickness of this sheet like reduces by the pass of each roll, and this leads to smoothing and compressing of material. So this is calendering. So this is not related to any of this process which is associated with casting. So the option of this question, or the answer of this question, is D, calendering. So please let me know if you have any doubts in this question, then we will proceed for another question.
No, sir.
No doubt. Okay. So this is one type of question which is usually asked, like what are the processes, operations associated with XYZ process. So you should know like what are the steps. Like let's say this is casting, so many other process would be there. So there they will ask like what are these steps included in this type of process or not. So you should know what are the process in particular operation. So coming to like a mechanical metallurgy question. This is the question 47 of GATE 2016 metallurgical engineering. Here the question asks us is first the fatigue behavior of aluminium alloy. Just a second. Is my screen visible?
No, sir.
Okay, just a second. Now is it visible?
Yes, sir.
Yeah.
Yes, sir.
Yeah, okay. This is GATE 2016 MT question number 47, which states that fatigue behavior of aluminium alloy is shown in SN plot. A piston rod made of this material is subjected to two different cycles. Like first is 1000 cycles at 420 MPa, second one is 1000 cycles at 300 MPa. So we have to find using Minor's rules of cumulative damage the remaining fatigue life of the material at stress at 250 MPa. So they have provided us with SN curve which states that for a particular stress level how much cycling is there before the material fails. So let's say for example 420 MPa. So for 420 MPa, if we cycle the material at 420 MPa, the material will fail at 2000 cycles. Similarly, for 300 MPa, the material will fail at 5000 cycles, and for 250, it will fail at 8800 cycles. So we have to calculate using minor rule like how much cycles it will take if it has like for 420 MPa it has undergone 1000 cycles, and for 300 MPa it has gone again 1000 cycles. So the material is having some history of fatigue. Now we have to evaluate how much cycles it can take more. So this is driven by like it is given by Minor's rule, which simply states that the failure occurs when the summation of individual damage values caused by each rainflow cycles reaches a value of 1. So where Nj is the number of cycles at a particular stress, and capital Nj is the lifetime of at stress, which is given by 2000, 5000 and 8800. So we have to basically sum this, and this sum should be total 1. So here I have done that. So 1000 cycles at 420 MPa divided by the number of cycles which is the lifetime of that material at that particular stress level, plus 1000 cycles at 300 MPa divided by the lifetime of at 300 MPa, which is 5000 cycles, plus let's consider x number of cycles it will sustain before it fails eventually, and this is the lifetime at particular 250 MPa. So if we sum this, and this should be equal to 1, which a minor rule states. So if we calculate, x comes out to be 2640 cycles. So the material will take 2640 cycles before it will fail eventually. So this is the question which can be answered in this way. So if this is understood, like do you have any questions on this question? Doubts? Is this question clear? Any doubts regarding like what is fatigue and everything? You can ask any question regarding this question, or you want to have some science behind it, like how this curve is generated and xyz. Any question you can ask me.
Sir, how we can write the equation of that curve?
This
We can
equation, like you
generate.
can this is basically a power law kind of thing. So basically you can have different softwares and you can just like curve fit this equation, so you will get equation of this curve. So what we usually do is, like, let's say if I plan a fatigue experiment, what I will do, I will have like 5 different points. Let's say at 600 MPa I cycle it till failure, so I will have this point in mind. Okay, so I will do this for different types of stresses. Let's say 600, 500, 800 and 200, and I will record the time or number of cycles it will take to failure. So I will generate 5 points on this curve and I will curve fit it using any software to get this curve out of it. Now you are able to like, let's say I had data for 200 and 400, but I don't have any data of 300. So using this curve you can easily say that for 300 it will take 5000 cycles to failure, like that.
Thank you, sir.
Yeah. Other question regarding fatigue and Miner's rule? If not, let's proceed to some other question. Like, again, I have taken from same GATE 2016 metallurgical engineering question 53, which states that for casting a cylindrical aluminum bloom having a length of 1000 mm and diameter of 750 mm, the approximate solidification time which they have specified in minutes estimated using Chauvinot's rule is, like, there are 4 options, like 45 minutes, 316 minutes, 440 minutes and 620 minutes, and they have given the mole constant to be 2 seconds per mm square. Now we have to find out how much time it will take using this rule for this aluminium bloom to get solidified. So they have given dimensions of the bloom as well as they have given the mold constant. So firstly we should know what is the Chauvinot's rule. So Chauvinot's rules of solidification suggests that the section of casting having a large volume to surface area will take a long time to solidify. So let's consider that you have a block and the heat extraction from that block is happening on because of the surface area, right? So the all the volume if the block is there, the energy or the heat which is stored in the volume will be transferred to the surface and from surface to the mold. So this is how the heat extraction will take place. So more the surface area, it will take less time to solidify, or in other case large volume to surface area will take more time to solidify. So on basis of that, the solidification time T is governed by this equation, which is K into the volume to surface area ratio square, and K is here the mole constant. So we know we need to find out what is the volume by this basic like geometry, like length is given, diameter is given, and it is a cylinder. So volume will be pi r square L, and area of the cylinder will be the curved surface area, which happens to be 2 pi r L, and the top and bottommost area, which is pi r square plus pi r square, means 2 pi r square. So this is the area, this is the volume. You know V, you know A, and you have K, so you can easily find out the time. So I have calculated here by this equation. Just I have put it this, pi r gets cancelled and you can do simple calculation to get 37,190 second. Note that we require to give solidification time in minutes, so convert this seconds into minutes, which comes out to be 620 minutes. Hence the option is D. So you have any doubt regarding this question, just ask me. Simple mathematics is there. You have to calculate volume, you have to calculate area, and if you know this equation you can easily find out the time required for casting to get solidified. Yes,
Yes, sir, that's fine.
that's fine, right? So let's
Yes,
move
sir.
on to last question for this session. So which is GATE 2016 Metallurgical Engineering question number 23. The question states that for a dye penetrant test, identify the correct statement. Options given are pre and post cleaning of parts are not required. Option B, internal defects can be detected. Option C, surface oxides help in crack identification. And option D, dye with low contact angle is required. So first, let us understand what is dye penetrant test is. So dye penetrant test is widely used a non-destructive method to like detect surface defects. So why surface defects? Because we apply a liquid which is a dye penetrant a dye on the surface, and this dye penetrates into these surface defects, and we remove the excess material, which I will tell you in further how are the steps, and we are able to predict where the defect lies on the surface. So this is basically a non-destructive method which is based on the capillary action. What do you mean by capillary action is like if fluid it will directly penetrate into the defect, and you can easily able to like find out where the defect lies using an ultraviolet light. When we put ultraviolet light over the surface, so this dye will reflect some different color, and you will be able to predict that the crack is present on the surface. So here you can see this is a schematic, and this is the liquid drop which you assume as a dye you are pouring on the surface of the material, and this is the wetting angle. So let's say if the wetting angle is very high, so this if wetting angle is very high, then the dye won't flow on the surface and it won't penetrate into the defects. So we require as low as wetting angle as possible. So when alpha tends to be 0, good spreading is there on the surface of the material. Hence we require a dye which has a low contact angle. And the steps required in this process are basically, first is pre-cleaning. Let's say the surface is having dust, oil and everything. So if the surface is having these things on it, so it is the dye won't be able to go to the cracks which are beneath this oil and everything. Hence pre-cleaning is required, and dust removal is required. Second, after pre-cleaning, you put this dye or penetrant on the surface, and when you give like sufficient amount of time so that this dye penetrates inside the all the cracks and everything, and then you remove the excess penetrant on the surface. You remove the excess penetrant from the surface and you apply the developer. So developer, what it will do, it will just try to detect from where the dye is not getting removed, and we will be able to know the defect detection. And after that, for we will have post cleaning. So these are the steps involved in dye penetrant test. So now again coming to the options, like option A, pre and post cleaning of parts are not required, which is not correct. It is like a mandatory process in dye penetrant test, so this is incorrect. Internal defects, sorry, internal defects can be detected, which is wrong, because the dye only can go to the defects which is readily accessible, and internal defects cannot be accessed. C, surface oxides help in crack identification, which is false. Like if the surface is having oxide, so the crack like the dye cannot penetrate the crack, and we were not able to identify the crack which is beneath the surface oxide. And D, dye with low contact angle is required, which is ultimately true. So here the answer is option D. Okay. Hello.
Yes, sir.
Again my screen got hanged, is it?
Yes, sir.
Okay. Hmm. Now you are able to see?
Yes, sir.
Yeah. So just a second. Some issue is there. Some issue is there with PowerPoint. Till what point I was there?
Sir, the full question number 23 was completed.
It was over, right?
Yes, sir.
Yes, sir.
Okay. Till it loads, you have any doubt? Like you want something from the session which you think might be helpful for all of you? Anything?
Sir, live poll will be much better, sir, if we attempt the question first.
Live poll in what sense you are saying?
Sir, in Google Meet.
Okay. Yeah, means like today we are going through 4 questions, right? Like that every session will be conducted. So apart from that, like what you guys want, that's what I was asking.
Sir, in the respective question, sir, if poll is generated, that will be good because we will be able to
Okay,
answer.
you mean to say like in live sessions I will give some time to you and you will write some chat box, in chat box your answer.
No, sir, no, not chat box, but in activities, there is an option for generating poll where we can click and write, मतलब आंसर सर मतलब वहाँ ऑप्शन रहेगा ना तो हम क्लिक कर देंगे इसको टिक.
Okay, I will have to see like what can be done.
Okay.
This is not responding. Okay. I guess I am finished with this question number 23, right? So I don't need
Yes,
to
sir.
Yes, sir.
go to. So this was the last question for today's thing. So one thing is like you want some polls, like so where you can answer these things, right? Is it right?
Yes, sir.
Okay. So one thing is, so if you can see me, and another thing, any suggestions from your side how we can take this session more efficiently? What the NPTEL office told us is to solve previous year questions in front of you, and all these questions will be available on this website. We will like have a recording of these questions and we will just upload it, so you can again go through this solution of these questions. And apart from that, I am asking like what exactly you want so that you can do better in gate and everything. One thing is like I will give you
Important formulas.
important formulas, yeah. That is the that thing you can do like when you are like having sessions, like you are uh, like videos will be shared with you, I guess, for all the topics. Is it NPTEL shares these videos with you?
No, sir, we don't know where from where to access those videos.
Okay, because what I know, like I just joined NPTEL like few weeks before, so what I know is like they share you the link of all the topics from where you can study that all the topics. There in their detailed explanation of all the science behind all the questions is there, and from there I guess you can extract all the all the formulas and you can write in one single sheet, or some kind of that exercise you can do while understanding the science, like learning as well as writing all the formulas through 1 or 2 sheets. That can be done. And when any, like let's say if you are solving, like if you are attempting to solve any particular gate, let's say 2015 gate question paper, then you try to solve every question where the formulas are there. Like let's say out of 55 questions, 25 questions are there where formulas are required, and you have the sheet of all the formulas. Try attempting all the questions. So if you have skipped any formula, you can again go back to that notes or video lecture, and you can write that formula which was absent in your sheet, and you can like modify that sheet according to your needs, so that all the formulas are there in like 2-3 sheets. Hence later you will find it easy to revise also, and you will get more like your study will be like more or less focused, rather than like, okay, I don't know this formula, then I have to search again in book or video. That won't cause in later stages. Now you have time, like August is there, but December you won't have time. So this sheet will help you in like having like directly knowing the formulas, and revising it daily on a daily basis will help you. Like most of the questions are like knowledge based question and formula based questions. So you will have a knowledge based questions, like 60-70% of questions are knowledge based, and rest of them are formula based. So you need to know like how you divide time also. Like let's say formula based questions are very easy, just you have to apply one formula and find out. So first you can solve these questions when you are attempting GATE question paper, any question paper, and try to have maximum time for the questions where you require to derive anything, where you don't know. Like let's say like one question is like any knowledge question, so you are not understanding like what the thing is, so you will require more time in that to think. And that, so first solve all the formula based questions and then come to the main questions. So like that you can plan accordingly. So I will give you tips like how you can like attempt a GATE question paper. But here now firstly we will start with 4 questions each session, and then we will go about things. Is it fine for you?
Yes, sir.
Yes, sir.
And any particular topic which you feel that you guys are not confident at, we will take more questions of that. That can also be done. Like we have a team of 4 people who will be solving previous year questions for GATE Metallurgy. So I am starting this session, and again Friday there will be one more session, and on Saturday 2 more sessions are there. So we all 4 will try to cover all the topics, means like, and you can suggest us like which particular topic you feel which is very important for GATE, and we will try to focus on that questions. And few questions if you see are repeated on, like every year they will ask a similar type of question, so you should know these type of questions, and we will try to cover that also. So you know like how is the what is the procedure to solve these questions very efficiently and very fast. So that is the whole process behind this plan of having 4 students completely dedicated to solving previous year questions. Is this okay?
Yes, sir.
Yeah, and firstly we will start with GATE 2016, and rest of the videos I guess till 2018 are uploaded on NPTEL GATE portal if I am not wrong. So you can go through these videos, and we will add this 2016 videos also, and we will go previous years like 15, 14, like that we will go.
Yes, sir.
Okay, then if you don't have any question, let's stop here for today, and you can join another session on Friday at same time, I guess. The links are shared with you, right?
Okay, sir. Yeah, okay, sir.
Yeah, okay. Okay then, bye bye. See you.